Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. Hyperbolas. Now, as we kind of get through towards the end of this video series, we've been studying conic sections. And if you've been kind of tuning into those other videos, which I recommend, you know that we've been doing parabolas, circles, ellipses, and hyperbolas. And it's important to know what the equation form is so that you can look at an equation in a certain form, look at the structure, what some of the numbers are, and then be able to just do a quick graph sketch. So we're going to talk about a hyperbola, what it is, what it looks like, what the parts are, and then how the equation form is determined. We'll also have a problem set, the next video here, where you get to try this, and then we'll finish this entire series with a self-quiz. All right, let's get started with hyperbolas. So hyperbola is this fourth type of conic section, and that's where you have your two cones here and you're going to slice straight through. You're going to end up having two curves. Now, one will be a U-shape, one will be an upside down U-shape, and there's a separation between the two of them. It's almost like having two parabolas. You remember a parabola is from a conic section that looks like this. All right, well, a hyperbola has certain properties. Let's take a look at that. All right, here's an example of a hyperbola where it opens up through the left side and the right side. Okay, now it can also open up and down, but I'm going to kind of keep it simple for now, and we'll do kind of a left-right hyperbola shape. Notice how there's a center, and there's a vertex over here, which is the end of one curve, and the vertex over here, which is the end of the other curve. All right, now here's the general formula before we start making it a little more complicated. It's an x squared term over an a squared term minus, notice the subtraction there, y squared over b squared equals 1. All right, now let's kind of break this down. The a part, remember it's a squared term in the bottom here, but if you can figure out what a is, that's going to be, notice how it's under the x, that's going to be the distance from the center horizontally. All right, so you're going to go out that direction in a positive way and that direction in a positive way or a negative way, and that's the a distance. All right, so that'll kind of tell you how far apart those curves are. All right, then we look at the b part. The b part is how far up from the center you're going to go and how far down. All right, so the equation itself kind of tells you how far apart the curves are and kind of a dimension here. Now, when we have the A's and the B's figured out, now let's draw a rectangle. So here it is, and we're going to put it in there. And the reason why we need a rectangle here is think of it as kind of a cushion between the curves of the hyperbola. All right, the last thing we need to talk about is something called an asymptote, which helps us draw the rest of this blue curve. Now the asymptote is going to go through the diagonals of that rectangle. Okay, now my hyperbola curve has not been drawn too accurately, and so we'll have to kind of use our imagination here a little bit. But the idea is that if you go through the diagonal there, then the hyperbola legs is going to approach that asymptote. Now I didn't draw it very well. In fact, let me kind of adjust it here. So once we know the center and the a and the b distances and we draw our square, then right diagonally through those the corners of that rectangle or square, we have our asymptotes. All right, so I'm going to start at the vertex here, and if I draw it a little bit better this time, what we're going to do is we're going to approach the asymptote. We're actually never going to hit and touch, but this is going to be a little more realistic curve there, and it will go forever but get closer and closer and closer and never quite get there. All right, and then go in the other direction. our curve is going to look something like that and like that. All right, it will approach the asymptote but not ever touch it. All right, well, you get the idea. And again, the standard form of the hyperbola is x squared over a squared minus y squared over b squared equals 1. Okay, now to be a little more realistic, let me give you the full equation of a hyperbola. All right, we've added an h and a k number, and inside the parentheses you have to have a subtraction value there. So it's x minus h quantity squared instead of just x squared, and y minus k quantity squared instead of just y squared. Everything else is the same, and the reason why we add the h and the k in there is because the center of this hyperbola is going to show up at h comma k. So this is the formula you'll have to remember. Now the first one I showed you is when h and k are 0, so this center would be at the origin. All right, let's look at a couple of quick examples. All right, we have this equation. We want to draw the hyperbola. What does that look like? Well, in the first group here it says x squared, which is really x minus 0 squared. And so we know that the h value is 0. The k value is right here at 3. Okay? So the center of this hyperbola has got to be at 0, 3. Now it's a positive 3. So we're going to go straight up 3 and locate the center right there. All right, let's look for the a and the b values. Well, here 4 is really 2 squared. So of course a has to be 2. Here 9 is really 3 squared. That's kind of convenient because then b must be 3. All right, so from the center, a value is 2. That means that we're going to go out to the right 2 and back to the left 2. All right, from the center, we're going to go up and down 3 because that's the b value. Right there and right there. Let's draw a rectangle. All right, there it is in light gray there, and then we go through the diagonals of that rectangle to draw the asymptotes. So let me draw it out this way and this way. All right, let's draw the curve. All right, we're going to start at the vertex here, and we are going to move towards the asymptote and approach, and don't have a very steady hand there, so not going to be very pretty, but it's going to be something like that. Start at this vertex here and curve up towards that asymptote, approaching infinity there, never touching it, and down here going that direction. So in the blue there, that is my hyperbola. All right, one more example. All right, let's look at here. We've got x minus 2 quantity squared, which means that 2 is the h value. And it says y plus 3. Well, remember, it needs to be in terms of subtraction. So y take away negative 3. And so the k value must be negative 3. The center's got to be at positive 2, negative 3. So over 2 and down 3. That's the center of my hyperbola. All right, then from there, 25 is really 5 squared, and 16 is really 4 squared, keeping it fairly simple here. So a must be 5, and b must be 4. All right, so from the center, let's go 5 to the right, put a little mark, 5 to the left, put a mark. Those are my a values. And then back from the center, we're going to go up and down 4. So put a mark right there and put a mark right there. Let's draw the rectangle. There it is. And now we draw the diagonals of that rectangle for the asymptotes. Let's give that a shot right there. And let's try, we'll go here and then we'll extend the line. All right, now let's draw the curve. All right, it is going to be approaching the asymptote, coming down towards the vertex, and then approaching the other asymptote, something like that. Arrowheads indicating it goes forever in that direction. and from near the asymptote, curving and coming around this way. All right, not very pretty, but you get the idea. All right, the next video is going to give you the equation of a couple of things to try, and you will locate it on the graph. Good luck, and thanks a lot for watching this video. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live, online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard and take care.